So, are you seeing my screen now?
Yes, we can see your screen.
Okay. So, this is the outline for week 2 as we have stated yesterday. Types of operators or operations in Python, conditional statements, loops. And we treated the first one, which is type of operation that we have in Python. And we say in Python we have this number of operations: arithmetic operations, comparison operators, and logical operations, assignment operation, membership, and identity. We've treated arithmetic during our first week, so we just keep it and move on to the comparison. Normally, from all of this comparison downward, each of the operation normally return a Boolean value, either true or false. And for the comparison, you are checking if whether we have equality sign, you are checking if whether two variables are the same. Not equal, you are checking whether if two variables are not the same. Greater than, you are checking if the left side of your expression is greater than the right side of the expression. For the less than, you are checking if the left hand side is less than the right hand side. For greater than or equal, it's just the same thing but matched. For the greater than or less than or equal, what we have explained yesterday is that you have to check the two conditions. But if the first condition satisfies, it doesn't need to check the second condition. Just like we have stated, like if you have the example we've treated yesterday, right? Is like we say, if you have, let's say, 20 is less than or equals to 30. So based on this, if you look at it, the first thing it will do is that if you check the first expression, is 20 less than or equals? So if 20 is less than, that's our first condition. Just like in this scenario, we have less than C less than or equals to A, which C is 30, we've defined A as 20 above if you could remember yesterday. So what we have done here is that the first thing the compiler does is it check the first expression which is greater than. If it is greater than, C is okay, this is less than, C is 30, A is 20. It will first check if C is less than A. By C 30, A 20, definitely C is not less than, so it's check the second condition again, which is equality sign. So it's 30 equals to 20, it is not done, then we have our false here. But if in any essence, you check the first condition like this, based on this case, A is 20, B is 20. So it check the first condition, is 20 greater than 20, it's not, then it moves on to the second one. But if the first condition satisfies, it doesn't need to check the second condition. And we move on to logical operators also. Logical operators, we have three, or sorry, we have and. And normally works with two expressions side by side. Each two returns a logical Boolean operator. So if this side is true and this side is true, then we'll be having true for and. We've even drawn a short truth table because of it and explain how the and works. So for and to return a true value, both of side of it should be true. That's how and works. If this side is false from the beginning, so the compiler will not even bother checking the second part. As long as it encounters and here, it just return false. But if this is true, it has to check the second part. If it is true also, then we will having true as our answer. If the second part is false, then we will have false as an answer. Then we have O. O statement. In O statement, if either part of this expression is true, then our answer is true. Just like in this case, we say if the first condition here is true, then it doesn't bother checking the rest of the part of it, so the answer is true. But if this is false, it check the second condition. If this is true, so there is no need for the compiler to go to the rest of the expression. It just return true. That's how O is. If one part is true, so the rest of the expression returns true. Then we have not also, and for not, it just negate whatever is given. If you're given like a true and you negate it not, it will return false. Then just like this example, we have not true. So not true inverse, it just invert whatever Boolean expression you have there. So if not true, it will return false. In this case, what it does is it checks whether is A not equals to D. If A is equals to D, then whatever the answer here, so definitely this answer is false. Then we negate the false, we have our true value here. Then we have membership operators. For membership, we have two operators there, in and not in. In you are checking the existence of a certain variable within a list of sequence. So we define x as 23561, and we have names here. So then we say for in x. That means we are checking if 4 exists within this x sequence. So based on this, we know that 4 doesn't exist here. So definitely we'll be having false. And the same thing for names here. We are checking for a in this. Despite having so many a's here, what we do here is that by assigning a in this quotation, it's just like we are taking a alone as a string exists, not as a like a single entity. So if you want to access a single entity, I said we will be treating it later on when we move into slice indexing. So definitely we don't have a single A as an entity here, so it will return false also. But if to say that we take another thing separate apart from A, let's say O Awal, Idris, Igwe, O Hajara, so definitely we'll be having something like true here. So not in is just inverse of one thing. In this essence, you are taking the existence. In this one, you are taking the non-existence of it. So we have the next one, membership. The is and not is. Yeah, the is and not is. What happens is that the membership it checks the memory location. That's what it do. That's the difference between in and is. In this membership, in the membership operators. Okay, sorry, this one is something. It's not membership. Let me check. Uh, membership and identity should be identity. Yeah, something like this. So in identity, difference between membership and identity is that membership checks the existence of a value, and in identity, it checks whether they have the same memory locations. Are they pointing to the same direction? That they compare memory locations. Are they the same pointing to the same memory location? If they are pointing to the same memory location, then we will be having true. Else, we will be having false. So the same thing is not is taking, it's just like the inverse of it. If the memory location is not the same thing, it will return true. If they are the same, it will return false. So that's what we've treated yesterday. And I say we'll be starting the conditional statement today, quite really. So conditional statements Python are a fundamental part of controlling the flow of execution. Like they allow the program to execute certain blocks based on the specific conditions or criteria, like making decisions and other stuff there. This statement enable branching, where different sequence of instruction can be executed depending on. Like what conditional statement does is that just like in our real life scenario, like let's say you said if never bring light, for example, you iron your clothes or you let's say wash the dirty ones. So this is just a simple scenario of if statement, conditional statement. You get two conditions here. If never bring light, you will iron your washed clothes. But if they did it, you will wash the dirty ones. So this is just one of the examples. So that means if there is never, so definitely you are not washing, you will be ironing. But if there is no never, you are not ironing, you will be washing. So that's just a simple scenario. We are like into it almost every day in our life. But here we'll be seeing it in Python programming language. And the first conditional statement we'll be encountering is if statement. If, just like the simple scenario I've given just now, if NEPA bring light, I will iron my clothes. If, that means if they bring light, I will not even bother going like looking into washing my clothes again. But if they didn't bring it, then if NEPA didn't bring light, then I will be ironing my clothes. So that's just how if statement works. If the first one is true, so there is no need for you to go. Hello, are you hearing me? Yes. So in if statement, just like I've just explained, is the simplest part of it. Just like let's take this as an example. X is being defined. Let's put it here. Let's say I have this list of, for example. So let's say I want to check whether a certain like is the CGPA of a certain student um is in a first class 2-1. Is it 2-1? Yeah, 2-1 first class second class upper or not. So I declare my CGPA as 3.5, and then followed by my if statement. If that means if, for example, CGPA is greater than or equals, let's say 3.5. This is one of the simplest examples we have it. And one thing, if you could remember, we've explained this as if whenever you're dealing with any function in Python, you end it with a colon. Any function or conditional statement, any statement you are dealing with, conditional statement or function, you end it with a colon. So by ending this statement with a colon, as I press enter, it will automatically indent it for me. The indentation differs upon the ID you are using. For this one, the default indentation I'm using now is 2, but you can increase it. 1 is okay, you can use 1, you can use 2 spaces, you can use 3 spaces, you can use 4, depending upon your liking. But one thing is that try to maintain it as you started. If you started with a single space indentation, try to maintain single space indentation throughout your code. If you started with a double space indentation, try to make it double space indentation throughout your code. That's how it should be. So now I'm using double spaces. So as I press colon, press enter, it will automatically indent it for me. It will know that whatever I'm going to write depends upon this single line statement. If I finish writing whatever I want under this if statement, I should like press something like backspace or delete to make my cursor back to normal space. So let's say if CGPA is greater than 5, I should be printing, okay, print, let's say something like, let's say second class, for example. Upper. So this is just simplest if statement that we are having. CGPA is 3.5. I've declared the CGPA. So if CGPA is greater than or equals 3.5, so I'll be having second class upper. So if I press this, just running this thing, that's all. It's connecting to the timer. So you see second class offer. The reason is that the if statement I've said is check this condition. Normally, this conditional statement they goes hand in hand with the logical operators that we'll be having. So if this CGPA is greater than, the first thing is to check my CGPA I've defined here is 3.5 and I say 3.5 here. It will check 3.5 is greater than 3.5. No, it's not greater than. And then it will check the second condition. Are they equals to yes? Yeah. 3.5 is the same thing as 3.5. So to print whatever statement is based on this indentation. But if I come here and after this I press, let's say delete, bar enter, then I delete this. If you look at where the cursor is blinking now, whatever I've written here, whatever I've written here is not part of my if statement because the indentation is normal here. So let's say I say print, let's try check it. finished. So let's say I print this. So what will happen is that we see both of them were printed, but the last print statement I'm having here is not part of my if statement. If you want to check whether that's true or not, let's try this. Let's reduce the CGPA, let's say to 3.0. In that essence, what will happen is the CGPA will be compared. Is CGPA greater than 3.5? 3.0 is not greater than 3.5. Then it will check for equality sign. Is 3.0 equals to 3.5? It is not. So in this essence, the whole of this if statement will not be printed. The whole of it will not be printed. So if you play this cell, a single cell here, our last statement, this print finish will be printed. The reason is that initially, look at the indentation. This indentation here shows that this print statement is not part of this if statement. The print statement under the if statement will not be printed, but this one will be printed. The reason is because of indentation. We have explained this during our week one. Python put more priorities on indentation than any other thing. So indentation matters whenever you are writing your Python code. Try to make it a little bit. So when you play this cell, you see that it will not print the second class upper because our if statement is not true. So this conditional statement they executed only and only if the condition at that certain level is true. If not, then they will go on to the next statement. That means if you have it, you are coming into that also. So that's just simple example of it. If CGPA, like whenever this is not true, so whatever statement we'll be having will not be true. We'll come to a very complicated one, like we'll work on this next. And that's the case of, let's say in this case here, we want to make it a little bit flexible. Okay, if it is not second class offer, so then what again? So here, when you put 3.0, nothing happens here anymore because this statement is not true. So what if we want to check whether it is like lower than that? Then something is being introduced by Python. If else. Hello? Hello?
Okay, Awal.
Uh,
So from the explanation, CGPA, if CGPA is greater than 3.5, it didn't print anything because the statement is false, right?
yes.
That means once the statement, if the if is false, you will not get anything,
You don't get anything.
anything in return.
Yes.
Okay, okay, okay. All right, thank you.
The statement under if condition only executed whenever like this if statement itself is true.
Okay, okay.
If it is not true, then whatever comes after it will just be ignored. So so if we want to make it a little bit flexible, let's try this. Let's say we define our CGP again. Let's say 3 equals, let's maintain the same value, and we say if CGPA is greater than or equals to 3.5, then remember that at every statement, let's say this conditional statement we're having, the end of whatever if or else, try to put this column. Because without this column, it is something entirely. So if I didn't put this column, press enter, look at the indentation, it goes straight into the normal indentation space. Because the semicolon I'm putting here is telling the compiler that okay, whatever you're going to do next, indent it to my default indentation space that I've described. So by pressing enter, by default, it's know that okay, after colon, whatever next line follows, it will be below that same expression. So let's repeat the same statement here. Second class upper. So what if we want to make it a bit flexible? Okay, like if this statement is not true, then what will you do? In this scenario, if it is not true, nothing happens here again. If CVP not greater than or equal to 3.5, nothing will be printed, nothing will happen here. So what if we want to make like find an alternative process in the sense that whenever this statement is not true, do this instead. Just like the example we've started with, like if never bring light, you iron your clothes, but if they didn't bring light, you wash the dirty ones. So this is just a single scenario of this. If there is light, you'll be ironing your clothes. Else, you'll be washing the dirty ones. So in this scenario, just like if you take it in this essence, so just take the first statement. If the NEPA bring light, I will iron my clothes. So in this scenario, you didn't define the second part of your condition. What will happen if there is no light? You didn't define it here. But during with the help of this else statement, it will make you that make a little flexible for that to accommodate for you to accommodate that in your statement. So if the CGPA here is false, what will happen is it just goes directly to for the else. See what I have done here. If you press enter, the indentation will continue unless if you press backspace. So therefore it will delete the indentation and start afresh. The else part must be at the same line as your if statement. So I press enter. My semicolon and my colon, then press enter. The indentation continues. So what will happen if what do I want it to print if the the if statement is false? Let's say for example, let's make it second. Okay, let's start bit by bit. Second class, let's say lower. For example, let's make it. So in this statement, this code what it does is that if this statement, my if statement is not true, then the else part will be considered. But if this is true, it will not consider the else part. That's how it works. If the first if statement is true, it will not even consider this else part. But if this statement if statement is false, then it will consider the else part. So one thing is that the else part will be executed only and only if the if statement is false. But whenever this statement is true, so my else part will not be printed here. So in this scenario, I'm having 3.0 as my CGPA. So if I run this, what will happen is if since the if statement is false here, 3.0 is not greater than or equals to 3.5. So definitely when I press this, I should be having second class lower because this statement is not true. But if I let's say I make it back to 3.5, if I run this, it will just run the first part of the print statement. It will negate the else statement. If I run this, I will be having second class upper now as my output. See, second class upper. So the if statement, whenever if the if statement is true, the else part will not be printed. If the if statement is false, then my else part will be considered. So that's how if statement works. And it even gets more complicated than this. Apart from this else or if and if, we can have more than one else if statement. It's a single one. Else if then else, but we can have more than one condition. So by having more than one condition, let's try to make this if else if. Let's try to make this code a little bit complicated. So in a CGPA format, we've known that we are not just having two classes, first class upper, second class upper, second class lower. There are so many options we have. So what if we want to consider all of the ranges? We have first class, we have second class upper, we have second class lower, we have third class. Yeah, something like that. So, yeah. So what if you want to involve all of them here? You cannot just be repeating else. Else works once, and if works once also. So if you want to make it a little bit flexible, then the concept of if else if comes in. And in Python, we write it as elif. So my first statement is I will define my CGPA. Defining this to avoid override. Let's say uh, whatever value I should be having here, you can put it for yourself. Then my if statement, if CGPA, let's just do this. Control C, Control V. So if CGPA is greater than or equal to 3.5, so what will happen now is that let's start with let's consider the first class. First, we know 4.5 upward is the first class. So the first class, if it is 4.5, then let's make it, then we press enter, we press it's the same thing. The else if statement should be at the same line as our if. So else if, that's how it is. But in Python, we don't write else if entirely, just like other programming languages. So we abbreviate it as elif, the else and if. Then whenever, just don't forget your semicolon, your colon, I mean, press your colon and press enter. The indentation continues. Then you print. So in the elif, okay, let's complete the elif. In the elif, yeah, you are having like you want to check now. The first if statement checks if my CGPA is greater than 4.5, so it will return first class. And then what will be the next range of values I should have? It should be something about 3.5. So then I can check CGPA if it is greater than or equals to 3.5. That's for the elif, the first elif. If it is greater than or equals to 3.5, what we printed is, let's say, second class, should be second. That's the first elif statement. And the elif can keep on going. There is no restriction of number of elif that should be having. But try to make it a little bit readable and understandable. So if the CGPA is greater than 3.5, we should be having second class upper. Then okay, this should be it. Then our next statement, let's make it elif also. Elif. Then we'll check for the second class lower condition. So CGPA, if it is greater than or equals to what? What's the range of 2.5? I think, 2.5. Second class lower, or something like that, if I can remember. So we should print second class lower, then our last expression. Normally, else should be the last. Else print uh, third class. So the same explanations, everything, it starts with the first one to check if my given CGPA here is 3.6. So whatever is being imputed here, it goes and check it here. If it is if it is greater than or equals to 4.5, then first class will be printed. If it is greater than or equals to 3.5, then second class upper will be printed. If it is greater than or equals to 2.5, then second class lower will be printed. And if it is else, that's our last condition. That means if all of these conditions, the if statement, the elif is not satisfied, then print this. If you remember, I said if one condition is satisfied, then it just truncated the rest of the conditions below. So if the if statement here is true, it doesn't even bother going to the elif and else. But if this is false, then it looks for this elif statement, the first elif here. And if this is false also, it goes here. If all of this if are false, then it prints the else part. The else is just like a backup plan you should be having. If your plan fails, then do this for me. So this is just one of the simple one. Let's try around this also. This is second class upper because I'm having 3.6. So what if I have, because it checks this 3.6 is not greater than equals to 4.5, so it goes here. But what if I have something like 1.6? So what happens is check 1.6 is not greater than or equal to 4.5, 1.6 is not greater than or equal to 3.5, and 1.6 is not greater than or equal to 1.5. So it goes here, print the last part of it. Else, once I print it here, Okay, but let's try something else. Is this else really necessarily? Let's try and see. Is it necessary to have else statement in any if condition? No, it's not necessary. You see, I just commented the else part and the program doesn't print anything because all of these if conditions are not true. The if is not true, the elif is not true, the second elif is not true. So because of like I've commented the else part is not there anymore. So this that class will not be printed. So it's not necessary for you to be having else part at the end of any conditional statement, but it's preferable to have it because it's just like a backup plan. Whenever your if statement fails, then it will serve as your backup plan for the if statement. But we can make this a little bit more fun and more interactive. So let's say this I'm having a CGPA value constant. What if I want to make it like a little bit flexible? I want the user to insert the value himself. If you could remember those that are there here during the first week, we've treated how to insert values. We've treated how to input values in the Python programming. If you could remember clearly, use input statement. Input, then you pass the message you want to be displayed on the screen. Let's say enter, for example, your CGP, for example. So this should be printed on the screen. But if you could remember also, when I run this, it will print an error. It will result in an error for me, if I can remember clearly. The reason for the error, let's run it and see. It will return an error. Let's say I'm having 4.3. Let's enter. I'm having error not supported between instances of string and float. You see, string and float. Because if you look at this statement, my 4.5 is a float. This one is a float, 3 point value with a decimal place. 2.5 is a float. But I've inserted my CGPA. If you look at the CGPA also, it's 4.3. Physically, it's a float. But if you could remember, we say that any imputed value by default is a string. Python. Any value that you have imputed using a keyboard is a string by default. So now what compiler does is it treats this 4.3 as a string and comparing using these comparison operators between string and float cannot be done, which is a type you cannot support. So if I want it to be as it is, then I have to convert my input into a dedicated data type. I'm dealing with CGPA, which CGPA like this with something in a float format, 3 point something, 1 point something. So definitely what I should be doing is should then cast my CGPA directly at its being imputed. So it's float initially 3 points, so I should be saying float, then put the whole input statement as a parameter of the plot. So if I run this again, now the error will be gone. Because as I imputed my CGPA, it will be automatically converted to a float value, then the comparison will take place. Let's run it and see. These network issues. Okay, let's start explaining something before. And we can have nested condition. If we say nested condition, what we mean is Sorry for the disruption. This Nigerian network, I don't know. So let me try 3.2 here. Please enter second class lower. So the reason for this is because I think I run it twice. So that's how it is. Whenever you are imputing something like anything in Python, by default that one imputed value is a string. If you want to manipulate it further, maybe if it is a float or integer, you have to typecast it, convert it into that data type using this format. So if I want it to be integer, I can just say int here. So that's how we cast values in Python. So this is just one of the examples, and also we can have uh, nested conditional statement. So for the nested ones, that means I'm having a condition inside a condition inside a condition. So just like the one we've seen so far is just a single if statement itself, but I can be having other if statement within below if statement also. Let's have a simple example and see. So this nested if statement. This yeah. So in nested if conditions, you have let's say you have a certain conditions. Let's look at this. Let's make this our CGPA into something else. Yeah, entirely. Let's say I'm having, let's say I say if the CGPA is greater than or equals to hello, let's say 4.5, then print first class for example, then say elif, and let's make it 3.5 here. So if you could remember, see whenever you press enter, this the indentation continues. So in a nested if statement, you leave the indentation. So then you have another if. That means if the first condition is true, okay, I shouldn't be. Okay, let me remove this statement entirely. That means if the first statement is true, if my CGPA is greater than 3.5, then this second statement will execute the second if. Then I should be checking if the CGPA again, CGPA is greater than or equals, let's say 4.5. Yeah, press enter. If you look the indentation for this one also goes, I will explain it. Then if it is greater than, then print what I have copied. Then you can have your else here. Else print uh, second class upper. So what this does is the first thing is check if the CGPA I've imputed is greater than or equal to 3.5. Yeah, if it is true, then goes down into this and check. Since it is greater than 3.5, then okay, check it again. Is it greater than or equals to 4.5? If it is, then print first class. If it is not, so definitely it is second class upper. And I can have another one here. Let's say if you look at the indentation, I want the if statement now to be at the same my else statement should be at the same level as the if statement. So I should be having elif here, or I can have else probably whenever I feel like. Let's try the else part. Let's have elif and see. Let's just have else. So the else also I can have nested if here. Else if my CGPA is greater than or equals what should be the next one? It's 2.5, I think. Hello? Hello?
We are with you.
Okay. 2.5. Then print 2 second class. This one should have else also. Then print this statement and this statement will print the same thing. But if you look at the complications here, it's entirely different. The way this one is structured is entirely different from the way this one is structured. But they will give the same answer. So if I run this, okay, let me define my CGPA. No, I don't want the user input. Let me just define it. Let's say my CGPA equals. Let's try the first one. Let's say we have 3.7. So what will happen is it will check, is 3.7 greater than 3.5? Yeah, it is greater than 3.5. Then it will check again. Is the 3.7 greater than 4.5? If it is, then print first class. If it is not, then print second class upper. So if this statement is true, the first if here, it will not even bother going to the else part. But if this statement fails, then it will go to the else part. Let's try and see what will happen here. What will be our output? We have second class upper because 3.7 is greater than 3.5. Then it will check this if statement also. Is 3.7 greater than 4.5? It is not greater than 4.5. Then it will print this first class. If it is not greater than, then it will print. So based on this, our 3.7 is not greater than 4.5, so it will not print this. If you could remember, I have said that if the if statement is not true, then it moves to the else part. So the same thing applies at the inner ones also. So the first one is true, it goes to the second nested if statement is not true, then it moves to the else part. But if this statement is false, for example, let's say I have 4.7 here. If I run it, I should be having first class. From this else part downward are being neglected because this if statement satisfies the condition. The first one is true and the second if is true. So I should be having first class as my output here. And let's try the else part also. And we say 2.7, let's say 2 here. 2. So if 2.7 is being cross-checked at this if statement, it will return false here. And since this first if statement is false, so definitely it will just keep and go to the else part. So you have 2.7. 2.7 will be compared with this 2.5. 2.7 is greater than, so we should be having second class lower. So let's try it and see. Second class lower. What if we have something less than 2.5? Let's say 1.7. We should be having third class as our output. So you just make this thing very interesting. So you choose, is it this one or this one? So they produce the same output. So that's in every function you see in Python, any kind of a programming language, there is more than one ways of writing it. So just choose the efficient way. Normally we consider what we call time complexity analysis. So we consider which one runs faster and which consumes memory most because they run at different phases. The way this code will run is different from this one. The speed of completion differs. The complexity differs. the memory location this one needs and this one differs. So it's a very interesting fact. If you have time or you feel like you can do it, you can just go and look for data analysis and structures in Python for any programming. So they work the same. And any question about this nested stuff? Sorry, not speaking very fast. Okay, no question. Then we have uh, we call them ternary operators or conditional expressions. So instead of writing the conditional expressions as we've written here, we can just make it in a single line. Sometimes we call it lambda function. But let's stop at this. So if you look at this, you can have okay, let me this one example I'm using. Okay, let's use the simple example. Conditional expressions. So let's say we've defined A equals, for example, something like 6. Then we say boolean A, let's say boolean A, we're taking the boolean condition of A equals. So now we want to check initially, okay, let me just write it here. If, let me write it, if A is greater than, let's do it simple, is greater than 10, print A is greater than 10. Example, just simple, check else uh, print less than 10. So this is just simple if statement that we have. So if I run this, what will happen is, what I'm saying is, check the value of A. If it is greater than 10, print A is greater than 10. If A is less than 10, print A is less than 10. That's so simple if statement. But I can make it into a single line. A is less than 10 because A is 10. So so let me get down the system. Hi.